Okay, everyone, Assalamu alaikum. Let's begin. So we were doing differentiation, and in the last session, we talked about equations of tangents and also stationary points and their nature. So what have we done until now? Uh, this is the major thing that we've done. We talked about how to differentiate functions that look like this using the power rule, where you have some expression and raised to power some number. How do you differentiate it? You multiply by the power, you subtract one from the power, and you multiply by the derivative of the base of the power. That's what we did. And then we looked at some applications of differentiation. In the last class in particular, we talked about how to find equations of tangents and normals, right? That's what we talked about. In this case, what we needed to remember was that gradient of tangent at a point is equal to the gradient of the curve at that point, and the gradient of the normal is negative reciprocal of the gradient of the curve, right? That's what we did. And then we talked about stationary points and their nature. Stationary point is just another name for turning point of a function. We learned how we could find stationary points for any kind of function using differentiation. So whenever you have a stationary point, whenever you have a turning point, the derivative at that point is equal to zero because the gradient at that point is zero. Since the gradient is zero, you put the derivative equal to zero because the derivative is the gradient function of a curve. So you just find the derivative, put that equal to zero, and that gives you the values of x that you have at the turning points. Once you have the values of x, you put those values of x back in the original function to find the corresponding y coordinates as well. We did this in the last session. Then we talked about how to figure out if some point is a maximum point or a minimum point. That we said we would do using the second derivative, right? So the rule was if the second derivative is positive, the turning point that you get is a minimum point, and if the second derivative is negative, the turning point that you get is a maximum point. This was the summary of all that discussion, that you find the turning points by putting the derivative equal to zero, and you find their nature by figuring out whether the second derivative is positive or negative. Positive second derivative means it's a minimum point, and negative second derivative means it's a maximum point. This is what we have done until now. All right. Now, before we move on, I would want you to let me know if there are any problems, any questions from the worksheet that you have attempted and you were not able to do. We would like to start with those questions first of all today, so that we get some practice on the concepts that we've done. And then there's one concept that we want to do today, and that's increasing and decreasing functions. So what we mean by increasing and decreasing functions, and how to solve problems involving those functions. Okay, so that's the plan for today. Now, let me know first of all if you have any questions related to stationary points and their nature. I asked you to do the first row of the assigned questions at least from the worksheet. I hope you had the chance to attempt them. Does anyone have any questions yet? So I asked you to do the first row of questions. Any problems from the first row of questions? Okay, so some of them actually might involve increasing and decreasing functions as well. Let me just have a look at them. If they involve increasing and decreasing concept, we would cover that first before we do these questions. Okay, so let me go through these questions that you're asking about. So 14, 22, 33. Okay, so question number 14, part 3. Find the set of values of x for which this is an increasing function of x. Yeah, so we'll talk about this today. This is a concept that we haven't done at this point. Until this point, we will do that today. 22. Find the angle that this tangent makes with the x-axis. 22 part 2. Remember coordinate geometry, the last topic that we did. Remember this formula that we did: angle between a line and x-axis, angle between a line and angle between any two lines. For angle between a line and x-axis, you basically use this: tan theta equals m, right? So whatever is the gradient of the line, you say tan theta equals that gradient, and that will give you the value of theta, right? If it was any two lines, for that we said you could use this formula, m1 minus m2 divided by 1 plus m1 m2. We did this in coordinate geometry. So the second part of 22 that you're asking about, that basically asks about the angle that the tangent makes with the x-axis. So if you have already found the derivative of the tangent, which you, of course, you would have found in the first part for finding its equation, whatever is the derivative of the tangent, that's the gradient of the tangent, you put that gradient equal to tan theta, and you'll find the value of theta from that. Is that okay? How's it? You can do that now, right?
Yes, sir.
Okay, so that was a concept that we did in coordinate geometry. Okay, question number 33. Let's see that now. When the distance BC, tangent, normal. Okay, this is more coordinate geometry as well. Only the first part is differentiation. But let's just try this, because since the first part does involve equation of tangent and normal. So we can have a look at this quickly before we start our next topic then. Does anyone have any questions apart from this? Any other questions from the worksheet yet? Okay, so let me just start with this, and then we can cover the concept of increasing and decreasing functions after this. Okay, question number 33 from the worksheet. It says the diagram shows the curve y equals 6x plus 2 whole raised to power 1 over 3 and the point A which lies on the curve. The tangent to the curve at A cuts the y-axis at B, and the normal to the curve at A cuts the x-axis at C. Find the equation of the tangent AB and the equation of the normal AC. So that's the first thing that you've got to do. You've got to find the equation of a tangent and a normal. Both of them are straight lines. Tangent is a straight line, normal is a straight line. How do you find equations of straight lines? You need two things for that: gradient and a point. Okay. Now, which two lines are we talking about? We're talking about this line AB, that's the tangent, and we're talking about the normal, which is AC, that's this line. Now, both of these lines pass through this point A. So this point A lies on both of them. So we have a point already. Okay, this point lies on both the lines. We can use this in y minus y1 equals m into x minus x1. The only other thing that we need is the gradient of both of these lines, gradient of each of these lines. How do you find that gradient? You have the equation of the curve given. You find the derivative of the curve and put the value of x equal to 1. That will give you the gradient of the curve at this point. And then you find the equation of the gradient of tangent and normal from that. Let's try this. We have the equation of the curve. That is y equals 6x plus 2 whole raised to power 1 over 3. That's the equation of the curve. Let's first differentiate it. Now it's the power function. It's a power function. You have some expression raised to power 1 over 3. How do you differentiate it? You multiply by the power, it becomes 1 over 3. And then you subtract 1 from the power, whatever is inside the bracket, that remains the same. 1 over 3 minus 1, that gives you minus 2 over 3. And then you multiply with the derivative of what is inside the bracket. So the derivative of 6x plus 2, what would that be? That will be 6. And that's the derivative. That turns out to be 2 into, so if you do this cancellation, 6 over 3, that's 2, into 6x plus 2 whole raised to power negative 2 over 3. If you want, you can write that in the denominator as well, but that's your choice. So I could write like this, for instance, 2 over 6x plus 2 whole raised to power 2 over 3. So when the negative power goes to the denominator, it becomes positive. Okay, the sign changes. That's the derivative. Now we want to find the gradient of the curve at the point A. What do you do for that? You put x equal to 1, right? Let's put x equal to 1 in this. When we put x equal to 1, we get 2 over 6 into 1 plus 2 whole raised to power 2 over 3. Let's simplify this now. You can input this whole thing on your calculator as well. You have 2 over 8 raised to power 2 over 3. 8 raised to power 2 over 3 would be 2 squared, and that's 4. 2 over 4, that's going to give you 1 over 2 as the result. Okay, so that's the gradient of the curve at A. This is the gradient of the curve at the point A. Okay, so now that you have the gradient of the curve at the point A, now you can write down the equation of the tangent and the normal. Tangent and normal. The point is the same for both of them. The point is 1 and 2, right? These are the coordinates of the point that we need to use. What about the gradient of the tangent? Gradient of the tangent is the same as the gradient of the curve at that point. Gradient of the normal is negative reciprocal of that. What's the negative reciprocal of 1 over 2? That's negative 2. Now you write down the equation y minus y1 equals m into x minus x1. Let's use that. So we're saying this is x1, this is y1, and this is m. For the first one, we would say it's y minus 2 equals 1 over 2 into x minus 1. That's the equation of the tangent. And for the second one, we say y minus 2 equals minus 2 into x minus 1. These are the equations that we were looking for. They have not asked us to write the equation in any particular form. It's okay to leave it like this as well. If you want to leave it like this, that's perfectly okay. That's your final answer. Okay. That's the first part. Let's move on to the second one, part 2. Now it says find the distance BC. BC, that's the distance that we want to find out. Now, what is BC? It's the distance between points B and C. If we can find the coordinates of B and C somehow, we can find their distance, right? Now, what's B? B is the y-intercept of the tangent up to the curve. B is the y-intercept of the tangent. Okay. And what about C? C is the x-intercept of the normal. Okay. C is the x-intercept of the normal. We have both equations. We have equation of the tangent. In the equation of the tangent, what you do is you put x equal to 0, y to find the point B, right? B is the y-intercept of the tangent. How do you find y-intercepts? You put x equal to 0. Let's see what we get from that. Y minus 2 equals 1 over 2 into 0 minus 1. That gives you y equals minus 1 over 2 plus 2, y equals 5 over 2. No, it's in fact 3 over 2. Yeah, 3 over 2, which you can write as 1.5 if you want. That's an exact decimal. Generally, we prefer writing numbers as fractions. But if it's an exact decimal like this, 1.5, decimals are also okay. If it was like 2 over 3, then it would be better to leave it as a fraction because you can't write this number as an exact fraction, as an exact decimal. It'll be like this 0.66666 and so on. So it's better to write that as a fraction. But 3 over 2 here, that's an exact decimal, 1.5. It just stops there. It's okay to write that as a decimal as well. Okay, so y equals 1.5. That means the coordinates of A therefore are 0 and 1.5. Okay, now this is the equation of the normal. In the equation of the normal, you put y equal to 0 because you want to find the value of C now, the coordinates of C now. C is the x-intercept. How do you find x-intercepts? You put y equal to 0 for that. So you put y equal to 0 here. When you put y equal to 0, that leaves you with 0 minus 2 equals minus 2x plus 2. And you have 2x equals 4x equals 2. That means the coordinates of that point C are 2 and 0. So we have both coordinates. We have the coordinates of A and C. In fact, this was B, not A. The first one, this was B. B's coordinates are 0 and 1.5. C's coordinates are 2 and 0. You can find the distance between these 2 points now using the distance formula. You would say BC distance equals square root of x2 minus x1 whole squared plus y2 minus y1 whole squared. So you could say 0 minus 2 minus 0 whole squared plus 0 minus 1.5 whole squared. 4 plus 2.25. That will be square root of 6.25, square root of 6.25, 625, 2.5. Yes, that should be 2.5, I think. Right? Can somebody confirm this? BC turns out to be 2.5, right?
Yes, sir.
Yes, sir. Right? So, yeah, so that's the length that we were looking for, the length of BC. Okay. That's part 2. Let's look at part 3 now. Part 3 says find the coordinates of the point of intersection E of OA and BC and determine whether E is the midpoint of OA. Okay, so let's do it step by step. So they've asked us first to find the coordinates of the point of intersection E of OA and BC. So which two lines are we talking about now? OA, that's this line, and BC, that is this line. E is the point of intersection of these two lines. All right, E is the point of intersection. Now, how do we find points of intersections of any two lines? We solve those two equations simultaneously. We don't have any of these equations for now. In the first part, we found AB and AC. So we don't have any of these two equations. So first of all, we would need to find their equations. We need to find the equation of OA and the equation of BC. We need to find both of these equations first of all. All right. Now, let's see how we can do that. These are straight lines. OA is a straight line, BC is a straight line. How do we find equation of straight lines? We need two things: gradient and any point. In this case, we actually know y-intercepts of both the lines. For the first line, the y-intercept is 0. For the second line, this one, the y-intercept is b, which we now know is the 1.5. We found that in the previous part. So we already have the y-intercept. All we need is a point that another point that gradient of the lines, not a point. All we need is a gradient. Once we have the gradient, we can just input these values and y equals mx plus c, and that is going to give us the equations. Okay, so we have the y-intercept. We can put c. We can put y-intercept in place of c. We just need to find the gradient. Let's find the gradient of both of these lines. So we have OA and BC. Let's do that here. Part 3. OA and BC. Now, let's find the gradient of OA first of all. We have a point origin, 0, 0, and A, that's 1 and 2. What's the gradient going to be? Let me write that point here. So we have that in front, 1 and 2. That's the point A. So it's going to be 2 minus 0 over 1 minus 0. That gives you 2. Y equals mx plus c. Just use that to write down the equation now. It becomes y equals 2x, right? C is 0. Y-intercept, you can say that it's passing through the origin. So the value of c is going to be 0. This is one equation. Let's find the other one. We know the coordinates of B and C now. B is 0 and 1.5. Let me write that here. And C is 2, 0. We need to find the equation of this line now. Let's find the gradient. 0 minus 1.5 divided by 2 minus 0. That will be minus 1.5 over 2. That's minus 3 over 4. The gradient turns out to be minus 3 over 4. That's the gradient. Now we know the y-intercept as well. Y-intercept is this, 1.5. So we can write down the equation using y equals mx plus c again. M is minus 3 over 4. So that's minus 3 over 4x plus c. C is 1.5. You can write this as 1.5 if you want, or 3 over 2. Both of them are okay. These are two equations that we have. Let me write it as 3 over 2. Generally, in equations, we prefer not writing decimals. That makes things complicated. So we have these two equations. Now what we need to do is we need to find the coordinates of the point E on this diagram. This is the point E. E is the point of intersection of these two lines. How do you find point of intersection? By solving equations simultaneously. So now we solve these two equations simultaneously. We can just equate both of them. That gives us 2x equals minus 3 over 4, 3 over 4x plus 3 over 2. Okay, I can take the x term to the other side. That gives me 2x plus 3x over 4. That equals 3 over 2. Now do this on your calculator. 2 plus 3 over 4. That should give you 11 over 4. 11x over 4, that equals 3 over 2. Now make x the subject. 3 into 4, that's 12. 12 over 22, that's 6 over 11. The value of x turns out to be 6 over 11. Okay, that's a slightly weird value, but let's just see if it works or not. What's the corresponding of a value of y? Y value is 2 times x. Just input that here. That will be 2 into 6 over 11, which is 12 over 11. So the coordinates of E that I'm getting from this, they are 6 over 11 and 12 over 11. Now they've asked us to prove something after this, so that will kind of verify if this answer is correct or not. So let's just see what they've asked us to do after this. They've asked us to determine whether E is the midpoint of OA. How do you determine that? Whether E is the midpoint of OA? You have this point O, you've got this point A. Find the midpoint of O and A. It's not the midpoint, right? Yeah, so let's find the midpoint of OA. Midpoint of OA, what would that be? It doesn't look like it's going to be this, but we need to show the working. 0 plus 1 over 2 and 0 plus 2 over 2, right? The coordinates of O are 0, 0. Coordinates of A are 1 and 2. Just find the midpoint. The midpoint turns out to be 1 over 2 and 1. This is the midpoint of OA. So what do you say then? Has somebody confirmed this working? The coordinates of E are correct, right? Is that what you get?
Yes, sir.
Right? Okay, so that means E is not the midpoint, right? E is not the midpoint of OA, right? Because this is different and this is different. It's not the midpoint. Make sense? Any problem with this? Any questions, anyone? No problems?
No, sir.
Okay, so if there are no questions, let's start with our next concept then, which is increasing and decreasing functions. Okay, so let me start with this. Increasing and decreasing functions. Now, we actually briefly talked about this in quadratics before as well, in the very first topic that we did. We talked about this briefly there as well. Let me just remind you about it. Yeah, the second topic that we did, quadratics. When we were talking about graphs of quadratic functions, I think I mentioned this here. Yeah. So when we were talking about graphs, we said if it's a U-shaped graph, for instance, one side of this turning point, the graph is decreasing. On the left side here, you can see the graph is decreasing because the gradient is negative, right? It's going downwards. As you go from left to right, the graph is going downwards. So we say the graph is decreasing, right? From left to right, graph is going down. That means it's decreasing. If you look at the right side of the turning point, here, as you go from left to right, the graph is increasing. The graph is going upwards. Okay, so this part is called increasing, where the gradient is positive. That's the same concept that we have here. You could sometimes have a curve like this that we saw here. In this curve, on the left side, this part, the graph is decreasing. The gradient on this side of the graph is negative, right? If you were to draw a tangent at any point, the gradient of that tangent would be negative. So whenever a function is decreasing, its gradient is negative. Now, on the right side in this function, you can see the gradient is positive. So the right side of this function, that is increasing. This has positive gradient. Now, this is a function which is negative in some part and positive, which is decreasing in some part and increasing in another part, right? But there are some functions like this as well that are throughout increasing or throughout decreasing. That is also possible. So for example, you could have something like this. So sometimes cubic functions have a shape like this as well. This is one possible shape of cubic functions. Now this is always increasing, right? Throughout the gradient is positive here. On the other hand, you have cubic functions like this as well, for instance. You have exponential functions that look like this, right? They're also increasing. You have exponential functions that look like this. They're decreasing, okay? So basically the idea is whenever the gradient is positive, on the left side, you see the gradient is positive. These are increasing functions. On the right side, the gradient is negative. These are decreasing functions, okay? So what is an increasing function? We can write that down here. In increasing functions, gradient is positive. Gradient is positive. Now, since we will be talking about curves here, how do you find gradients of curves? Gradients of curves are found using differentiation. So what this means is, whenever you have an increasing function, the derivative dy over dx, that is going to be greater than 0. So in increasing functions, what you need to remember is dy over dx is greater than 0. So for this function, the derivative is always going to be positive for functions like this on the left side. On the other hand, if you have decreasing functions, what about those functions? When you have decreasing functions, let's talk about this. In decreasing functions, the gradient is negative, which means dy over dx is going to be less than 0. Okay, so that's the connection or relation of increasing and decreasing functions with differentiation. That's why we study this in differentiation, because when we have an increasing function, we can say the derivative should be positive. When we have a decreasing function, we can say the derivative should be negative. Okay, so sometimes a function is throughout increasing or decreasing like this. Sometimes it's increasing in some part, decreasing in another part. For example, a quadratic function that looks like this, it's decreasing on one side, increasing on another side. You can have cubic function like this as well. Sometimes, for example, if I have a graph that looks like this. Now it has two turning points, this graph. One turning point is here and another turning point is here. Now, this part is decreasing, as is this part. The part in the middle, this is increasing, right? So this is decreasing part of the graph. This is increasing part of the graph. And this is again a decreasing part of the graph. So this function as a whole, we can't say if it's increasing or decreasing. As a whole, it's increasing in some part, it's decreasing in another part. These functions are either always increasing or decreasing, so both possibilities can be there. What you need to remember is increasing functions have have a positive derivative, and decreasing functions have a negative derivative. Any problem with this? Any questions on this? Pretty straightforward until now, right? Now let's have a look at some questions from the worksheet related to this, related to increasing and decreasing functions. Let's start with that one, the one that you asked about, question number 14. That Hazim asked about. Let's start with that. Okay. Question number 14 from the worksheet. Let's have a look at this now. Okay. So it says the equation of a curve is y equals 1 over 6 into 2x minus 3 whole cube minus 4x. This is the equation of a curve. In the first part, we need to find the derivative of this curve. What's the derivative of this curve? dy over dx. Let's figure that out first. Y equals 1 over 6 into 2x minus 3 whole raised to the power 3 minus 4x. That's what the function is. Let's differentiate it. dy over dx. The constant multiplying outside remains as it is, 1 over 6. Multiply by the power, that's 3. Subtract 1 from the power, it becomes 2. Multiply by the derivative of the part that's inside, multiply by 2. The derivative of 2x minus 3 is 2. That's the differentiation of this first term. What about the second term? Minus 4x. Derivative of minus 4x is just minus 4. Now we could simplify this. 3, 6, and 2, they get cancelled. 6 over 6, you have 1. What are we left with? 2x minus 3 whole squared minus 4. That is dy over dx. Okay, that's what we had to do in the first part. We found the derivative. Okay, now let's look at the next one. The next part says find the equation of the tangent of the curve at the point where the curve intersects the y-axis. Now this is the equation of tangent. I hope you can do this. Okay, let me just try. Let me just do this quickly as well. Part 2. We have this equation, y equals 1 over 6 into 2x minus 3 whole cube minus 4x. That's the equation of the curve. We want to find the equation of the tangent at the point where the curve intersects the y-axis. Where the curve intersects the y-axis. That means the y-intercept of the curve. That is what we're talking about. How do you find y-intercept of a curve? Of any function, you put x equal to 0. So first of all, you need to find that point at which you have to find the equation of the tangent, because we need a point for finding that equation as well. Let's put x equal to 0 to find the y-intercept. That gives us y equals 1 over 6 into minus 3 whole cube minus 0. And that's minus 27 over 6, which can be simplified to minus 9 over 2. That's 4.5. That's the y coordinate. This is the point that we have then, 0 minus 9 over 2. Okay, this is the y-intercept. We could actually just use this now. What about the gradient? We have found the derivative in the previous part already. Just put x equal to 0 in that as well to find the gradient of the curve at this point. dy over dx was equal to 2x minus 3 whole squared minus 4. We want to find the gradient of the curve at that point as well. For that, we just input x equal to 0 here. That gives us 0 minus 3 whole squared minus 4. 9 minus 4 is 5. This is the gradient of the tangent. Right? It's the gradient of the curve, but the gradient of the tangent is going to be the same as this. That's what we were looking for. Okay. Now we can write down the equation. The equation is going to look like this. Y minus y1 equals m into x minus x1. What do we get from this? Y minus y1. In fact, we could actually use y equals mx plus c. That's going to be quicker because we have the y-intercept here. Just use that. Y equals mx plus c. That's going to give you y equals 5x minus 9 over 2. That's the equation of the tangent that we were looking for. Make sense? Any problem with this? Any questions, anyone? No? Okay, now let's look at the third part. In the third part now it says, find the set of values of x for which this expression, that's this function basically, is an increasing function of x. Find the set of values of x for which this is an increasing function. Now, what does it mean? Increasing function? When a function is increasing, dy over dx is greater than 0. So all you have to do is put dy over dx greater than 0, and that will give you a set of values of x. Okay. Now we have already found dy over dx. This was dy over dx. We found that in the first part. Let's put that here. Dy over dx is equal to 2x minus 3 whole squared minus 4. That's what dy over dx was. Okay. All you have to do now is you say dy over dx. This should be greater than 0. Why? Because it's an increasing function. They have given that the function is increasing. So we put dy over dx greater than 0. Make sense? Now we can just solve this quadratic inequality after this. We have 2x minus 3 whole squared minus 4 greater than 0. This is a quadratic inequality that we need to solve. How do we solve quadratic inequalities? We did this in quadratics. You treat them as an equation, first of all, to find the x-intercepts, and then you think of the graph to figure out which region is going to be correct. Okay, so treat this as an equation. 2x minus 3 whole squared minus 4 equal to 0. It's a quadratic inequality, right? How do we solve inequalities? We said we would treat them as equations. So it's an equation like this. We start like this, and then we solve this equation. 2x minus 3 whole squared equals 4. We take square root on both sides. That gives us 2x minus 3 equals plus minus 2, right? So 2x minus 3 is either equal to 2, or 2x minus 3 is either or it's equal to minus 2. The first one gives us x equals 5 over 2, and the second one gives us x equals 1 over 2. These are two x-intercepts that we're getting for this particular function. Okay, so we have these two x-intercepts. Now that we have found those x-intercepts, what's the shape of this graph? It's a quadratic function, and it's a U-shaped graph because the coefficient of x squared is going to be positive here. So it's a U-shaped graph like this. What we have done is we have found the x-intercepts of this graph. One x-intercept is 1 over 2, the smaller one, and the bigger one is 5 over 2. The inequality is that the function should be greater than 0. Which part of this function is greater than 0? It's either this side here or this side. That means it should be the left side of 1 over 2 or the right side of 5 over 2. So what's our final result then? We say x is either less than 1 over 2. Remember, these are two separate regions. You have to write them separately. You cannot write them as a single inequality. You would say x is either less than 1 over 2 or it's greater than 5 over 2. This is the set of values of x for which this function is an increasing function. So you just put the derivative greater than 0 because it was an increasing function, and then use to solve that quadratic inequality that you get from that. Make sense? Is this clear to everyone? Any problems with this? If you find this process of solving the quadratic inequality confusing, please make sure to revise quadratics. You need to make sure that you're revising alongside as well, because otherwise it's very common that you just end up forgetting what you've learned before if you don't do revision. Please make sure that you're revising the previous topics alongside doing practice on these topics that we're doing right now. No problems with this? No questions? Okay, so if there are no questions, now let's look at a couple of more questions involving increasing and decreasing functions. So you can look at your worksheet. There are some other problems as well that involve increasing and decreasing functions. Let me start with this one. This is question number 35. from the worksheet. In fact, let's do 36 first. That's, yeah, this is easier. Let's start with this one first. 36. Okay, so we have a function f of x that equals 2x minus 5 whole cube plus x. Now, we haven't done functions yet, yes, but all they're doing is they're just using this function notation, right? There's nothing else. Yeah, there's nothing else that is related to functions here. That we cover in the functions topic. So you should be able to figure this out without knowing much of the functions topic as well. F of x is 2x minus 5 whole cube plus x. This is a function that we have. Now, this basically means, this thing means x can be any real number. So basically, there's no restriction on x. That's what it means. X could have any value. X could take any value. All right, that's what it says. Now, given this function, what we want to do is we want to show that f is an increasing function. What's an increasing function? Increasing function is one that has its derivative positive. However, it's different from the last question that we did, because in the last one, they basically asked us to find the set of values of x for which the function was increasing. So they had given us that the function is increasing. Given that information, we needed to find the set of values of x. So we could just put derivative greater than 0 like this, and then solve that inequality afterwards. This question statement is different. They have not given us that the function is increasing, so we can't just put the derivative greater than 0 in this case. We need to show that the derivative is positive. We need to show that dy over dx is greater than 0. By the way, in this case, they've used function notation. So we could also use function notation here and say f prime of x, right? Show that f prime of x, that's what it means. Derivative is also denoted like this. F prime of x, that should be greater than 0. We need to show this. We can't assume this already that the derivative is positive. Okay, we have to show this. We have to prove this. Now, how do you do that? Let's find the derivative first of all. 2x minus 5 whole raised to power 3. How do you differentiate it? You multiply by the power. 3 into 2x minus 5 whole raised to power 2. Multiply by the derivative of the part that's inside. 2x minus 5, the derivative of that is 2. Plus x. X has a derivative of 1. Now let's simplify this. This gives us 6 into 2x minus 5 whole squared plus 1. That's what the derivative turns out to be. Now, we need to show that the derivative is positive. We need to show this. So do not do this. Do not solve it like an inequality like this. You can't do this. Okay, this is not given that it's greater than 0. You have to prove that it's always greater than 0. If it's an increasing function, that means it's like this, as in it's always increasing. You need to show that this derivative is always positive. How can you prove that? How can you prove that this derivative is always positive? Any idea?
By making a graph.
By?
In a graph function that is minus 5 to x minus 5 equal to 0, and from there we can coordinate of x and turning point, completing square form.
Yeah. So what you're suggesting is we say, think about this derivative that we have. It's a quadratic expression, right? It's a quadratic expression. What does this quadratic expression look like? If you were to sketch f dash of x, remember it's not the original function, it's the derivative of that function. If you were to sketch this, it would be a shape like this, right? If you were to find the turning point of this function, you would see that the turning point is basically positive. The y coordinate of the turning point is positive. You can try that. How do you find the turning point? This is not the standard completed square form. In the standard form, you used to have ax minus h whole square plus k. Inside the bracket, the coefficient of x was supposed to be 1 in the standard form, but here it's not 1. In this form, we used to say that h is the x coordinate of the turning point and k is the y coordinate. Now, if we have a coefficient of x here, like this, how do you find the x coordinate of the turning point in such cases? The part inside the bracket, you basically put that equal to 0. And that gives you x equals 5/2. That's the x coordinate of the turning point. And this is the y coordinate. That's 1. The y coordinate of the turning point is 1. This is the turning point of this derivative. That means the minimum value that this derivative can have is basically 1. So we can say minimum value of f prime of x is equal to 1. If the minimum value is equal to 1, that means f prime of x is always greater than 0, which means it's an increasing function. Is that okay? Is this all right? So we find the
Yes, sir.
turning point of this function. This is one way to think about this. You could also do it directly like this, as in showing all of this working was not necessary. A direct way of thinking about this could be, let me just take it to the side, or in fact, whole thing to the side. This could be one way of doing this. Okay, what we've done here, this could be one way of doing this, one way of thinking about this whole process. Another possibility could be that you just argue by looking at this expression. How do you do that? 6 is a positive number. 1 is a positive number. This part is a square, right? This part is a square. A square can never be negative. A square can never be negative, right? The least value it can have is 0. So basically what that means is this whole thing, this is always going to be greater than or equal to 0. And then you have plus 1 outside, which makes this whole thing greater than or equal to 1. So you could just think of this function like this as well, that the square part with 6 multiplying, it has a least value of 0. That means it always has to be 0 or more, 0 or greater than that. So the whole thing has plus 1 added here as well. So the whole function should be greater than or equal to 1. That means the minimum value of this derivative is 1. That means f dash of x is greater than 0. It's an increasing function. This part is very important. You have to mention this, that the derivative is positive. Since the derivative is positive, that is why it's an increasing function. So after finding the derivative, you basically say the derivative is greater than 0. That is why it's an increasing function. Is that okay? Make sense to everyone?
Sir, how do we write that second answer as an answer in the question?
This one?
No, the second method you just showed. How do we write that as an answer?
Just show this. So basically, the mark that you get is going to be on this. Okay? So in the marking scheme, they just mentioned this generally, that you, after finding this derivative, it's kind of obvious looking at it that it's greater than 0 because of this reasoning, that this part is positive, this part is greater than or equal to 0, and this part is greater than or equal to 1. So even if you just write this after this, after finding the derivative, even if you were to just write this, that is going to be sufficient for this proof. But I would suggest that you at least show something like this, that the square part is greater than or equal to 0 and the whole thing is greater than or equal to 1. That is why the derivative is greater than 0. Okay, but even this would get you the mark generally. Is that okay?
Yes, sir.
Okay, one last question before we end. Question number, the other one that we saw there, 35. Let's have a look at this. Question number 35 from the worksheet. Let's try this. Okay, I'll give you a minute to attempt this first, and then we're going to do it. This is 35. Tomorrow, we will be discussing rate of change. That's the last concept that we have in this topic. And we'll also try to do some questions from that. And hopefully, in the next class after that, on Tuesday, we can start integration, inshallah. But it depends on if you have any questions, we can discuss those questions first as well. But make sure to attempt as many questions as you can before tomorrow. So if you have any questions, they can be addressed. Apart from the rate of change questions. So apart from the last row assigned on Classroom, you should be able to do the rest of the questions before tomorrow. Okay. Tomorrow, we're going to complete the concepts as well. Okay, let's try this now. It says it's given that f of x is 1 over x cubed minus x cubed for x greater than 0. Show that f is a decreasing function. Again, we need to show something. We need to show that f prime of x, that means the derivative of the function, that is less than 0. Sorry, it's a decreasing function. That means it should be less than 0. Let's find the derivative. First of all, we can write this in the power form. 1 over x cubed can be written as x raised to power minus 3. And then we have minus x cubed. What's the derivative of this? F prime of x, that's going to be minus 3x raised to power minus 4 minus 3x squared. We can write this derivative like this now, minus 3 over x raised to power 4 minus 3x squared. We need to prove that this is less than 0 now. How do you prove this? What you can do is you can take, so you can see you have a negative sign here, and you have x raised to power 4. That's an even power. That's always positive. Even powers, the result of them is always positive, right? Similarly here as well, it's an even power. This is also always positive. And you have these negative signs with them. That means this whole thing is always going to be negative. But it's going to be easier to understand if you take minus common outside. In this expression, if you take minus common outside, that leaves you with 3 over x raised to power 4 plus 3x squared. Now this part is always positive, right? Why? Because 3 is a positive number. X raised to power 4 is always going to be positive because it says x is greater than 0. So x value cannot be 0, right? It has to be greater than 0. This is always positive. This is always positive for that reason. And you have a negative sign outside. So part inside the bracket is always positive, and you have a negative sign outside. What does that mean? The whole thing is always going to be negative. Okay. So what do you write then? You say, after converting to this form, then you just write f prime of x is less than 0. That is why it's a decreasing function. Make sense? Any problem with this? Any questions? Is this clear to everyone? So understand the difference between the statements. Sometimes you have to show that the function is increasing or decreasing. In that case, you'll do this. Prove that it's always positive or always negative. Sometimes they ask you to find the set of values of x for which the function is either increasing or decreasing. In that case, you put that greater than 0, less than 0, and solve that inequality. Okay? All right, I hope that makes sense. That's it for today. I'll see you again in the next class. For tomorrow, we will be doing rate of change, inshallah. Please make sure that you do practice so that we can discuss any problems that you have as well. All right, Allah Hafiz.